Students, good morning. This is your class number 3 of module number 4. And in the previous class, we have discussed the definition of KOM and followers, then classification of followers on different criterias. After that, we have discussed classification of KOMs also. Then in the yesterday's class, we have discussed different types of follower motions, right? And in the today's class, I will start some numericals on different types of KOM and follower. Okay, whether this screen is visible, what about my audio, whether it is clear or not clear, anyone, so that I can start with the numericals.
Yes, sir, it's clear.
Okay, thank you. Okay, so this is the first problem. So you can, what I'll do, I'll start with the numerical, and you can take the given things. Okay, after the class, I'll share this PDF, the Google Classroom. After that, you can practice with a drawing instrument and with a actual scale. Now you can do is can take a rough sketch, okay, of the displacement diagram and the KOM profile. Okay, so before that, I'll start with the problem number 1. Okay, a KOM is to be designed for a knife edge follower. Okay, just write down the keywords. Okay, please write down the keywords, and this problem carries 20 marks. Okay, so this problem carries 20 marks, in which you have to draw first a displacement diagram. After that, you have to draw a KOM profile for the first condition. Okay, and you have to draw one more KOM profile for one more condition. Okay, it means there are totally 3 drawings. Just note down the keywords. First one is a displacement diagram. The second one is a KOM profile for a radial type of a follower, and the last one is again the KOM profile for an offset type of follower. Okay, I'll start with the this problem number 1. KOM is to be designed. Means you need to design the KOM for a knife edge follower. Just note down the keyword. The type of follower is knife edge. Okay, and with the following data, the data is given that first data is KOM lift is equal to 40 mm. Okay, so first I'll read out the problem. After that, in the next slide, I'll list out what are the given things. A KOM lift of a 40 mm during 90 degree of KOM rotation with a simple harmonic motion. Okay, this is the outstroke. There will be 4 angles. Usually they'll give 4 angles. First one is when the follower is moving in upward direction. Okay, after that the dwell angle, again a return stroke angle, and the last one again a dwell angle. So first I'll read out the problem, and in the next slide I'll list out all these things and I'll explain once again. Okay, just write down the keywords, these underlined words, just write down those things. The KOM lift is nothing but the distance traveled by the follower, that is indicated by alphabet S. Okay, there is the displacement of the follower. It is given as 40 mm during 90 degree of KOM rotation with a simple harmonic motion. Okay, this is also very important. And the second angle is a dwell for the next 30 degree. And the third data is during the next 60 degree of KOM rotation, the follower returns to its original position with a simple harmonic motion. Okay, again the follower is moving in a downward direction with simple harmonic motion. After that, again there is a dwell during the remaining 180 degree. And you need to draw the profile of the KOM for 2 different conditions. Okay, draw the profile of the KOM when the first condition is the line of stroke of the follower passes through the axis of the KOM shaft. So this is nothing but a radial follower, in which the axis of the follower passes through the center of the KOM shaft. Okay, and one more condition is the line of stroke is offset by 20 mm from the axis of the KOM shaft. Okay, and the last one is the radius of the base circle of the KOM is 40 mm. Okay, so this is also very important. The base circle radius of the KOM is 40 mm, and determine the maximum velocity. You need to find out the maximum velocity and maximum acceleration of the follower during its ascent and descent. Ascent is nothing but whenever the follower is moving in a upward direction. One more name for this ascent is outstroke, means the follower is moving in upward direction. Descent means it is a return stroke. The follower will be moving in a downward direction. And the cam is rotating with a speed of 240 rpm. Okay, so this is the given data. Just wait for a second. So in the next slide, first I'll write down the given data. Okay, these are the data, and it is mentioned the problem. Just write down these things. Okay, just write down only the keywords. First, you have to decide what is the type of follower it is given in the problem. Whether it is a roller type, it is a knife edge type. Okay, so anyone, which kind of follower is this? The problem it is mentioned, you can see here. So the type of follower you have to design is a knife edge follower, right? So first I'll write the type of follower as a knife edge follower. Okay, so this is nothing but a knife edge follower, and this is the approximate shape of a cam. Okay, you have to design the profile of this cam. Okay, I have taken a rough diagram of the cam, but you have to draw actual profile of the cam. Okay, based on different conditions. Okay, and as I discussed in the previous class, the cam will be rotating through an angle of 0 to 360. Okay, the angle that is covered by the cam is 360. It is known as the angular displacement of the cam. Okay, as the cam starts rotating, the follower also starts moving in upward and downward direction. Okay, so and this follower will travel through some distance. Okay, so that is nothing but the stroke length of the follower. As the cam starts rotating, the follower will move in up and down direction, and the distance traveled by the follower from this point to this point. Okay, it is given as the 40 mm. So it has to be indicated with alphabet S. It is also known as the cam lift or stroke length of the follower. Okay, and one more data is given as a 40 mm. That is nothing but a base circle radius. Sometimes they will mention minimum radius also. Both are same. In the problem they will mention the minimum radius of the cam is 40 mm, or sometimes they will mention as a base circle. Okay, so you can see here the base circle of the cam is 40 mm. Correct. So I'll write on that one also. You can indicate with the small or capital R. Both are okay. And the speed of the cam is given. That is 240 rpm, and is 240. So in the last line, I think they have mentioned if the cam rotates at 240 rpm. Okay, and sometimes they'll mention the direction of rotation. Okay, if nothing is given, just take the cam is rotating in a clockwise direction. Okay, they'll mention whether the cam is rotating in a clockwise or anti-clockwise direction. If nothing is given, just assume that the cam is rotating in a clockwise direction. Okay, with a 240 rpm. Okay, then in the as I said, you'll be given a 4 angles. Okay, first one is the outstroke angle. Outstroke angle is nothing but the angle that is covered by this cam when the follower is moving in an upward direction. Just write down the keywords for upward means in the problem they will mention upward means outstroke also correct. Okay, ascent also correct. All are same. So here you can see ascent or the upward motion or the outstroke all are same. Just to be indicated with a suffix O. Okay, and before that I'll show the animation once again because most of the students were absent for the previous class. Okay, so this is nothing but a cam and yeah, just wait for a second. Yeah. Before that I'll explain once again about this one. Okay, so you can see this is the cam. This is a certain kind of a profile or the pattern of okay. Whether this screen is visible, this animation, anyone?
Yes, sir, visible.
Okay, So since most of the students were absent for the previous class, I'll explain once again. Okay. So you can see the cam is rotating through an angle of 360 from 0 to 360. Remember. Okay. And the follower is moving in upward and downward direction. Okay. And the follower may be of a roller type or a knife edge type. But in this case, in the problem, it is mentioned it is a knife edge. Okay. But don't worry about this one. Okay. I want to explain what is outstroke and return stroke. Okay. Whenever the follower is moving in upward direction, okay, upward direction. So what is the angle that is covered by this cam? Okay. When the follower is moving in a upward direction, what is the angle that is covered by the cam? That is nothing but theta naught or theta O, outstroke angle. Okay. Whenever the follower is coming down, then that time what is the angle that is covered by the cam? That is nothing but a theta R, return stroke angle. Okay. So outstroke angle is nothing but the angle that is covered by the cam when the follower is moving in upward direction, and theta R, the return stroke angle, is nothing but the angle that is covered by the cam when the follower is moving in a downward direction. Okay. And you can see between this outstroke and return stroke, or ascent or descent, or you can say upward motion or downward motion. So you can see in between it is taking some rest. Okay. So now it is rest. It will move up. It will take rest. Down. Rest. Up. Okay. In between outstroke and return stroke, it is taking some rest. It means there is no displacement of the follower. So I can call it as a dwell period. Okay. Whenever there is no movement of the follower, okay, between the outstroke and return stroke, that time whatever the angle that is covered by the cam is nothing but dwell angle. Okay. So this is the first dwell angle, this is the second dwell angle. Okay. So when the follower comes down, it will take some rest. Okay. You can see it is taking rest. Okay. That time whatever the angle that is covered by the cam rotation is known as a first dwell angle. Okay. After the follower moves upwards, now so you can see it is taking rest. Okay. After the upward stroke, again it is taking rest at this point. Okay. So that time whatever the angle that is covered by the cam is nothing but the second dwell angle. Okay. The first outstroke angle, okay, you can take any one, theta d1 or theta d2. Outstroke angle, the first dwell angle, return stroke angle, second dwell angle. You can take any one. Okay. So and whatever the distance that is traveled by this follower, this is known as S. Okay. From this point to this point, you can see just take any one reference point. Okay. So it is traveling to some distance. Okay. You can take the reference as the center of this roller follower. The distance traveled by the follower is nothing but the cam lift, that is given as 40 mm. Okay. And the base circle radius is given as 40 mm. That is also same. Okay. I'll go back with this one. Okay. Yeah. So I think the working principle of this cam and follower is clear, and the stroke length is given as 40 mm. The base circle radius. Okay, I'll explain what is exactly the base circle radius while explaining the cam profile. Okay, it is also called as a minimum radius, that is 40 mm. The speed of the cam is given as 240. So if nothing is given, just assume that the cam is rotating in a clockwise direction. In the bracket you can write clockwise. Okay, and the theta naught is given, that is 90 degree. Also they will mention what is the kind of motion of the follower. Okay, as I said, when the follower is moving in upward direction like this, okay, it is following this kind of motion, simple harmonic motion. And in the previous class I have explained 4 different types of follower motion. Okay, the follower will be moving with a uniform velocity or uniform acceleration and deceleration, and one more simple harmonic motion, and the cycloidal motion. Out of those 4, they'll mention, okay, what is the kind of the follower motion during its outstroke, whenever the follower is moving away from this cam, means upward stroke, that is given as 90 degree with simple harmonic motion. Just write down. Okay, in the problem they'll mention, you can see the cam lift during a 90 degree of cam rotation, means the follower is moving in upward direction. Lift means upward, 90 degree with simple harmonic motion. They'll mention the kind of motion. Okay, the theta naught is 90 degree. Next, dwell angle. after the follower moves in upward direction, it will take some rest. It will not suddenly come down. Okay, but the cam will be rotating continuously. Okay, the cam will not stop in between. But the follower moves upward, it will take rest. It will come down again. It will take rest. Okay, so as I said, the theta naught is nothing but the angle that is covered by the cam during the upward motion of the follower, that is given by 90° with simple harmonic motion. After that, for the next 30° rotation of this cam, there is no movement of the follower. The follower stays in the upward position only. Okay, the displacement is 0. So that is the first dwell angle. Okay, that is nothing but 30°. So after that, for the next 60°, for the next 60° of the cam rotation, the follower will come down. Okay, so that is nothing but a return stroke angle, theta r. R means return stroke. O means the outstroke. So it is also given with a simple harmonic motion. So in the problem they'll mention, during the next 60° of cam rotation, the follower returns to its original position with simple harmonic motion. Okay, so it is clear that the follower, whenever it is moving in upward direction, the kind of motion is simple harmonic, and whenever it is coming down, that time also it is simple harmonic. Okay, and the last one is theta d2. Okay, after the follower comes down, that is the return stroke, again it will take rest for next 180°. Okay, it will not move at all. Okay, so this is the given data, and just take a note. Okay, so during the outstroke also, return stroke also, the kind of follower motion is simple harmonic motion. Okay, just take a note of this one. If it is clear, I'll go with the displacement diagram. If any doubts, please ask, because it is important to write down the given data. If you do any mistake in the given data, if you misplace these angles, you'll get 0 marks. Okay, since it is a 20 marks problem, the data should be correct. Okay, just check whether it is a radius or a diameter. Okay, this is a radius. So anyone from 4th A division, I think, any doubts? Sumit, is there any doubt?
No, sir.
Okay. What about from 4th B and C division? I think most of the students from diploma background, I think they have studied this. Anyone from 4th B? Okay, what about 4th C? Is there any doubt?
No, sir.
Okay. In that case, I'll go with the displacement diagram. Okay, before that, it is asked to find out the maximum velocity and acceleration. Just it is given that determine the maximum velocity and acceleration of the follower during its upward stroke and return stroke. And in the previous class, I given this list of formula, okay, for different kinds of follower motion. So in this case, it is a simple harmonic. Okay, there are 3 set of formula. One is for uniform acceleration and retardation motion. One more is for simple harmonic motion, and one more is for cycloidal motion. So since in this case both the outstroke and return stroke is of a simple harmonic motion, I'll take all these 4 formulas. Okay, so first write down this formula. Just take this table. Okay, so first I'll consider the outstroke. So you can see the outstroke is with a simple harmonic motion. Okay, outstroke is simple harmonic motion, which means I'll select these 2 formula. This is nothing but the maximum velocity. O indicates, you can zoom inside, zoom your screen, and you can write down this formula. You can see the suffix O max. It means the maximum velocity of the follower during outstroke. Maximum velocity of the follower during outstroke. That is nothing but pi by 2 omega s theta naught. Okay, omega is nothing but the angular velocity of the cam. So you can use this formula to find the angular velocity. That is 2 pi n by 60. Okay, n should be in RPM. N should be in RPM. Okay, that is the maximum velocity of the follower during outstroke, and then find the maximum acceleration. So pi square by 2 omega square s divided by theta naught square. Theta naught is nothing but the outstroke angle, and it has to be in the radians. If it is in degree, just convert into radian. Okay, and I'll go with the Written stroke. The written stroke is also simple harmonic motion. It means again I'll go with this second row. Okay. So a written stroke, the maximum velocity during a written stroke, maximum acceleration during written stroke. Okay. So I'll select these four formulas. Okay. So I noted down this formula so that I can go with the next slide.
Wait, sir.
Okay, please write down. At least for the first two problems, you may face difficulty while solving the problems, but in the examination, you'll get the exact same problems. They'll change the conditions. Okay, so please practice this model. This model is very important from exam point of view. Okay? They'll change the condition and they'll change the angle, but the problem will be same. Okay. If you're done, I'll go with the next slide.
Yes, sir.
Okay. Okay. So first, you need to find the maximum velocity of the follower during outstroke and return stroke. Correct? So at a time, I'll find the maximum velocity. First for outstroke and return stroke. Okay. And you can see the formula is same. For the outstroke, the maximum velocity, and for return stroke, the maximum velocity formula is same, except this for outstroke, you have to mention the outstroke angle, that is theta naught. For return stroke, you have to mention theta r, return stroke angle. Only this will change. Same also for acceleration. Only this theta naught will change. For outstroke, it is theta naught. For return stroke, it is theta r. Okay, the formula is same. And remember the angle. The outstroke angle is 90 degree. Okay, you need to convert into radian. How much it is in terms of radian? You can multiply by pi by 180. It'll become pi by 2, correct? Okay, since it is in degree, just convert into radian. For that, you have to multiply by
1.57.
Okay, okay. So have you multiplied with pi by 180?
Yes, sir.
Okay. Similarly, just remember the return stroke angle is 60. Again, you have to convert into radian, pi by 180. It means pi by 3. Let pi by 3. Just calculate that. Outstroke is 90, return stroke is 60. So first I'll start with the maximum velocity of the follower. Just write down this maximum velocity of the follower during outstroke. The formula is this one. To calculate this, the known things are this. The cam lift is given. It has to be in meter. That is a 40 mm. Make it as a in terms of meters. Okay, it will become 0.04. Theta naught is given. That is a 90 degree. Just convert into radian. Only the unknown thing is this angular velocity, omega. So before that, I'll find the angular velocity of the cam. So omega is equal to 2 pi n by 60. Okay, 2 pi into the n is given. What is the value of n? N is given as 240 rpm. It has to be in rpm. Okay, 2 pi n by 60, n is 240. So that you are getting this much answer, 25.14. So please take your time and calculate this one. Omega is equal to 25.14. Yeah. After that, just find out the maximum velocity during outstroke. Pi is known, omega is this 25.14. S is given as the cam lift, that is 40 mm. When you convert into meter, it will be 0.04. Okay, all the dimensions should be in meter, rpm, and radian. 2 and theta naught is 90 degree. This convert into radian, 90 into pi by 180. Look at this much, 1.571. So finally, the maximum velocity during the outstroke is 1 meter per second. Okay, and similarly for return stroke, what is the maximum velocity of the follower? Same formula. Instead of theta naught, I'll take theta r. Okay, theta r is I think 60 degree. Just convert 60 into pi by 180. It will become in radians. You'll get the answer as 1.51 meter per second. Okay, please take down this note. Theta naught and theta r should be in radians. And you have to select the formula in such a way that it should be with respect to the simple harmonic motion. Out of that table, there are so many formulas. You have to take the formula with respect to simple harmonic motion. There is nothing but this simple harmonic motion. So I have selected these formula, these two. Okay. So if you're getting these two, I'll go with the next one. That is a maximum acceleration of the follower during outstroke and return stroke. Okay. So again, write down the formula from the tabular column. That is nothing but for simple harmonic motion, I want the maximum acceleration during outstroke. It is a naught max, this formula, and during the return stroke, it is ar max. Again, this formula. That is pi square by 2 omega square s theta naught square. Same formula. For return stroke, I'll replace theta naught by theta r. Only that is the difference. So just substitute the values, that is pi, omega, s, theta naught should be in radians. Theta r is also in radians. S should be in meter. So how much you'll get? A naught and AR. You'll get A naught as 50.6 meter per second square and AR as 113.8 meter per second square. So getting the same answer. Anyone, please reply so that I'll go with the displacement diagram. Anyone from fourth semester C division, we're getting the same answers or any doubts?
Yes, sir.
Okay, thank you, thank you. Okay, if it is clear, I'll go with the first one, that is a displacement diagram. Okay, so what I'll do first, I'll explain what is the,
Sir.
yeah, any doubts? Yeah, what is it?
Wait, sir. Calculating, sir.
Okay. So I'll give another 30 seconds. Please make it fast. In the next 15 minutes, I'll explain the displacement diagram. Okay. So don't ask in between any doubts. After the completion of the displacement diagram, you can ask the doubts. Okay. So that since the time is 15 minutes remaining, so first I'll complete the displacement diagram. Okay. After the class, I'll share the video and you can practice with the drawing instruments with the actual scale. Okay. For the time being, you can take a rough diagram, okay, so that you can aware of what is the exact method to draw the displacement diagram. Okay. For the next 15 minutes, please take a rough diagram. So after the class, you can practice with the drawing instrument and with the actual scale. Okay. So you can calculate these things later also. Okay. I'll share the notes in the Google Classroom. Okay. And I'll start with the displacement diagram. As I said in the previous class, displacement diagram is nothing but along the x-axis, I'll take the cam rotation angle, that is from 0 to 360. I'll take the scale as 1 centimeter is equal to 20 degree. You can take any scale, but for A4 sheet, this is a best scale. Okay, if you're drawing on A4 sheet, this is a best scale. Along the x-axis, I'll take 1 centimeter is equal to 20, 2 centimeter is equal to 40. It means for 360 degree, what is the distance? It will be 18 centimeter. Okay, 360 by 20. Okay, 20 degree means 1 centimeter. Okay, for 360 degree how much? Okay, means 360 by 20. You'll get 180. Okay, and along this y-axis, I'll take the distance traveled by the follower. Okay, that is stroke length. So it is given the maximum stroke length is I think 40 mm. That is 4 centimeter. The y-axis also I'll take the scale as 1 centimeter is equal to 1 centimeter stroke. Okay, 40 mm means you have to indicate the 4 centimeter. And I'll take all the dimensions in centimeters. And the angle will be in degrees. So here you can see the instructions. I have given the instructions about this slide. Okay. After the class, I'll share this a complete slide. So first, draw x-axis, draw y-axis. Along x-axis, I'll indicate the cam rotation angle from 0 to 360. Along the y-axis, I'll indicate the stroke length, that is the distance traveled by the follower. Okay. So since I want to indicate total 360 degree, 0 to 360, correct? It means 20 degree means 1 centimeter. For 360, it will be 18 centimeter. So I'll mark 18 centimeter along the x-axis. So that 18 into 20, you'll get 360 degree. Okay. And along the y-axis, I'll indicate the distance traveled by the follower. That is nothing but the cam lift or stroke, which is indicated with alphabet S. Okay, it is given in the problem. It is 40 mm. 40 mm means 4 centimeter. Okay, I'll indicate this 4 centimeter along the y-axis. Okay, after that I'll complete one rectangular box. Okay, I'll complete a rectangular box. You can see the instructions indicate length 4 centimeter on y-axis. So this length is corresponding to the stroke length of the follower, that is cam lift. After that, what I will do first, I'll indicate the 4 different angles. Okay, the first angle is how much? The outstroke angle is 90 degree. Okay, correct. 90 degree means how much? 90 by 20. So you have to indicate 4.5 because 1 centimeter is equal to 20. Okay, so to indicate 90 degree, how much it is? 90 divided by 20. So it will be 4.5 centimeter. Along the x-axis, using the scale, just indicate 4.5 centimeter and draw one box. Okay, so because in the problem it is given the outstroke angle is 90 degree. And what is the next angle? Anyone? I think you noted down the first dwell angle, how much it is? 30. Correct?
Degree.
It means 30 by 20. How much? 1.5 centimeter. Correct? 30 by 20. Because 20 degree means 1 centimeter. 30 degree means how much? Okay. So 30 by 20 will get 1.5. For the next 1.5, just indicate. Yeah. Any doubts? No. So for the next dwell angle, that is 30. 30 by 20 means 1.5. I'll indicate 1.5. So please mute your audio. Okay. And I'll indicate the next angle. Okay. Outstroke means the follower is moving in upward direction. Then dwell, it means it will take rest. Again, it will come down. That is a return stroke angle. So how much it is? 60. 60 by 20 means 3 centimeter. For the next 60 degree, the follower is returning back. Okay, that is a 3 centimeter. And the remaining will be, that is 180 degree. Next dwell angle. Outstroke, first dwell angle, return stroke, and the second dwell angle. So as we noted, the second dwell angle is theta d2. 180. 180 by 20 is 9 centimeter. Okay. So this method is common for all the problems. Okay. And after that, after indicating the outstroke angle, first dwell angle, return stroke angle, and this second dwell angle, what I will do, I'll divide this outstroke angle into 6 equal parts. Okay, you can take any number of equal parts, but to get the exact cam profile, approximate, it means very near to the cam profile, you have to take 6 equal parts. Okay, if you have more time, you can take 8 equal parts also. Okay, so how much it is? Just calculate. I want to divide this 4.5 centimeter into 6 equal parts. 4.5 divided by 6.
0.75.
0.75. Okay. So I'll indicate 0, 0.75, 0.75, 0.75 with the help of scale, so that I'll get 6 equal parts, correct? And I'll give the naming. This 0, 1, 2, 3, 4, 5, 6. Okay? And I'll not divide this dwell angle. I'll leave as it is because there is no movement of the follower itself. Okay, the follower is under rest. Okay, it is not rising, it is not returning. The follower is under rest. So I'll not divide this dwell. I'll leave as it is. Then I'll go to this written stroke. I'll go to this written stroke. It means the follower is coming down. The follower is coming down. Just imagine the animation whatever I show, so that it will be clear. Okay. So again, I'm going to divide this written stroke into 6 equal parts. The written stroke is nothing but 3 centimeter. 3 by 6. How much? 0.5.
0.5.
0.5. Correct. Correct. So 0.5, 0.5, 0.5. I'll get 6 equal parts. So since the follower is coming down, so I'll give the naming in a reverse order. 6, 5, 4, 3, 2, 1, 0. Okay. And for the next dwell angle, I'll not worry about this because the follower is under rest. There is no movement of the follower. So for every problem, you have to divide the outstroke angle into 6 equal parts. So just calculate this 4.5 divided by 6, you'll get 0.75. Again, the written stroke is 3 centimeter because it is a 6 degree. 3 by 6 is 0.5. Okay. So this, up to this, it is common for all the problems. After this, it is common for all the problems. Okay. Now, in the problem, it is given that which method you have to use to draw the displacement diagram. As I explained in the previous class, okay. So the follower has the 4 types of motions. One is with a uniform velocity. One more is a simple harmonic motion, and one more is a uniform acceleration and retardation motion. Correct? Better I'll show that slide. Just wait for a second. Yeah. So these are the 4 motions, correct? But in this problem, it is given that the follower is moving in upward direction as well as the return in downward direction with simple harmonic motion. Correct? Simple harmonic motion. I'll take what is the method of simple harmonic motion. So this is for this method is for uniform velocity of the follower. This is for uniform acceleration and retardation. But I want the simple harmonic motion. What is the method? The method is known as a semicircle method. Okay. Since the follower is moving in upward direction with simple harmonic motion and it is coming downwards in a simple harmonic motion, it means for rising also, for returning also, it is simple harmonic motion. So first I'll confirm. Okay, it may change. Sometimes in the problem it will be given that the follower is rising with simple harmonic motion and returning with uniform acceleration retardation motion. Okay, since both rising and returning are with simple harmonic motion, I'll not worry. I'll use this method, that is a semicircle method. Okay, just remember why I'm choosing this method. After solving a couple of problems, you'll get to know. You can differentiate between one problem to another problem. So since the rising and returning is with simple harmonic, I'll use the semicircle method. Okay, for outstroke and a return stroke. So what I'll do, so near to this outstroke, I'll take total is 4 centimeter. I'll take the midpoint. I'll draw a semicircle like this. So you can see it. So draw a semicircle by taking the midpoint of this one. The total is 4 centimeter. The distance of 2 centimeter. I'll take a radius as a 2 centimeter. With the help of compass, I'll draw a semicircle. Okay, this method is only for simple harmonic motion. Remember. Okay, and what I will do, and I'll divide this semicircle into 6 equal parts. So since you have divided this x-axis into 6 equal parts, again you have to divide this also into 6 equal parts. Both should be same. If this 8 equal parts, this also has to be 8 equal parts. Okay, total angle is 180. Okay, 180 by 6, how much? 30 degree. So I'll indicate 30 degree, 30 degree, 30 degree, 30 degree, total 180. So that I'll get a 6 equal parts. So can zoom your mobile screen so that you'll get this one. Okay, so this is the reference point. I'm dividing this semicircle into same as this 6 equal parts. Total is 180, and just take the protractor and just divide into 6 equal parts: 30 degree, 30, 30, 30, 30, 30. Okay, and I'll give the naming as after that just join this midpoint to this. Okay, after getting this angles 30 degree, just draw lines. Okay, these lines will intersect this semicircle at point A. So this is point A, this is point B, C, D, E, F. Okay, so the next step is so from each point, from point A, draw a horizontal line. Okay, since both outstroke and return stroke is a simple harmonic. Okay, I'll not draw one more semicircle here. I'll extend the same line. Okay, from point A, I'll draw one horizontal line, B, C, D, towards a right direction. You can see the blue color lines. You can zoom in this outstroke and return stroke. From point A, I have drawn one horizontal line. From B also, C, D, E, F. So I'm extending to return stroke also because return stroke is also simple harmonic. Okay, and what I will do is, so these blue color lines are the horizontal lines that are intersecting these vertical lines at certain point. Okay, the first blue color line, this one, it is you can zoom in this part. Okay, the first blue color line is intersecting the first vertical line, that is the 1. So this, I'll indicate this as a 1 dash. Okay, this is the second line intersecting the second vertical line at this point. I'll indicate this as a 2 dash. This is 3 dash, 4 dash, 5 dash, and 6 dash. So first I'll note down the points. Okay, the intersection points between the horizontal lines and the vertical lines. First horizontal line and the first vertical line. Second horizontal line and the second vertical line. Third one and the third one. So after that I'll give the naming. Since it is corresponding to the first vertical line, I'll indicate this as a 1 dash. So this is 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay, so this is with respect to the outstroke. Okay, it means the curve is going up. You can see the curve is going up. After that, there's a dwell. I'll draw a horizontal line. After that, the follower will come down. It means the return stroke. For the next 60 degree, the follower is coming down. It is traveling through a distance from 4 to 0. So initially it is 0, it is going to 4 mm or 4 centimeter. After that, the follower has to come down. It means again these 6 horizontal lines intersecting these 6 vertical lines of a return stroke. Okay, you can see. So this is the first horizontal line, that is coming from F. It is intersecting this 6th line, this line number 6. So I'll indicate the intersection point as 6. Whatever the line that is coming from point E, so it will intersect the 5th line at 5 dash. Similarly, 4 dash, 3 dash, 2 dash, 1 dash. Okay, now I'll join all the points with a freehand line. Okay, I'll draw one line or curve passing through these all these 12 points like this. It means you can say that the follower is it is rising. You can see it is rising from 0 to 4 mm, 4 centimeter for the first 90 degree. Okay, after that there is no movement. For the next 30 degree of cam rotation, there is a 0 displacement. It means the follower is under rest. It means the curve is flat. When there is no movement, the curve is flat. Again, that after moving upwards, it will come down. The follower will come down from 4 centimeter to 0 centimeter, from 4 centimeter to 0 centimeter for the next 60 degree. That is nothing but a return stroke angle. It means the curve has to come down. Okay, it means you are plotting the cam rotation angle. Okay, from 0 degree to 360 degree, and from 0 to 4 centimeter. Okay, and you can join this also for the next 180 degree. So there is no movement. The follower is under rest. You can join this also with a flat curve. You can extend this blue color line. Okay, so this is nothing but the displacement diagram. Whatever you have discussed, this is nothing but a displacement diagram. And in the next class, based on this displacement diagram, I will draw the cam profile. Okay, it is difficult to solve this problem in a single class. Okay, so what I will do in the next class, I'll draw this. I'll explain how to draw this cam profile. So far we have discussed this displacement diagram. So if any doubts, please ask. Okay, otherwise I'll wind up today's class. Okay, please go through the notes what I'm going to share after the class and practice this displacement diagram. And if any doubts, can ask now also, otherwise in the next class also. Okay, so if it is clear, if it is
Sir, why we are
yeah.
Sir, how to divide that circle? A, B, C, D,
Okay.
E, F.
So here at this midpoint, so after drawing this semicircle, use the protractor. So keep your protractor at this point. Okay. So indicate the first 30 degree. Just indicate one point. Next 30 degree, one more point. 30 degree, 30 degree, 30 degree. So using the protractor, so keep the center of the protractor at this point. Okay, and take this vertical line as a reference line. Okay, take the vertical line as a reference line. The protractor has to be towards your left side. Okay, similar to like this. The protractor has to be like this, similar to this semicircle. The first 30 degree, indicate point E, D, C, B, A. Or you can start from here also. Is that clear?
For all examples, we have to take 30 degree only.
Yeah, because you are dividing into 6 equal parts, correct? The total angle is 180. 180 by 6 is 30.
Okay, sir. Thank you, sir.
Okay, so please practice this.
Sir, why you took the 6? Sir,
Yeah.
Sir, why you took the 6 division?
You can take a 4 also. If you take 4 equal parts, you'll get less accuracy. The cam profile will be less accurate. You can take 8 equal parts also, 10 equal parts, but it'll take so much time. Okay, because I'll explain the cam profile. So this is the cam profile. So you have to transfer the distances from the displacement diagram. So if you're taking 8 or 10 equal parts, it will take so much time. So this is the cam profile. This is the cam profile. Okay. To simplify the solution, we are taking the optimized equal number of parts, 6, so that you will get a more accurate this pattern of the cam profile.
Okay, sir.
Okay. So please go through the notes, whatever I shared in the Google Classroom. And if any doubts, I'll clarify in the next class. Okay. Thank you.